Water, water everywhere. But is it safe to drink? This lake may be fresh water, but I wouldn't take a swig. Hello, my name is Olivia, and today I'm learning all about water filters. Let's go to Questacon.
Hey Olivia, I see that you've been testing some different materials there. What have you observed?
Well, this material has been most successful at removing particles, and this material has removed some discoloration. But they're letting the water through very slowly. What if I needed to provide water for a whole community?
That's a really great question. The average Australian uses 340 litres per day. So flow rate is a really important part of water filter design. And when it comes to providing water for a whole community, I know just the person for you.
Hi Olivia, I'm Doug. I'm an army engineer here. Let's go see some of our water filters in action. The Australian Army often helps during emergency situations such as bushfire and flood recovery. During a bushfire, ash and debris can end up in a town's water supply, making it undrinkable. That's when portable water filters like these can come in handy.
So you can remove unwanted debris from the water?
Yes, we use a range of equipment to filter the water. That's because different water sources contain different substances within them.
In the Bega Valley, we drew water from a river, whereas on Kangaroo Island, we drew water directly from the sea to provide to the community.
This reverse osmosis unit can turn salt water into drinkable water. It can also remove the bacteria and particles found within it. This is some of the water from the creek that's currently going into these filters. Would you like to drink that?
Oh, no thanks. I'll wait until it's filtered. So how do they work?
Inside the filters is a semi-permeable membrane. This is a material that is so fine that the water molecules can pass through, but the contaminants cannot because they are larger.
But if the membrane is so fine, doesn't that slow it down? How can you filter enough water for a whole community?
We use powerful pumps to force the water through and improve the flow rate. These filters can supply up to 100,000 litres of clean, safe, drinking water every 24 hours. That's enough for about 290 people.
What are these for?
There's two important steps after filtration. One of these is chemical treatment.
Take a glass of lemonade. You cannot see the sugar or flavour. They are invisible to the eye, but still there, making it sweet and delicious. Well, the same goes for nasty bugs and heavy metals. We may not see them, but they are still bad for us.
These chemicals help us clean out those invisible impurities.
And the final step?
The final step is testing. This is when our medical team ensures that the water is 100% safe for us to drink. Shall we? Now that the water has been tested, we're ready to have a taste. So what do you think?
Perfect. You'd never know how it started out. Thank you so much. I've had a great time.
No worries. Good luck in your design challenge.
Okay, so I'm back at Questacon and I'm improving my water filter.
Hey Olivia, what have you got there?
Well, I've combined these materials to help remove particles and discoloration, and I've added this plunger to help me force the water through and improve my flow rate.
Well done. Do you think it's going to be safer to drink?
It's definitely an improvement, but I still wouldn't quite trust this filter with my water from the lake. Not unless I could do a chemical treatment and run tests, like the Army does.
Great idea.